Hello students, in this video I'm going to discuss some of the common mistakes that happened last week. So this question says the relative atomic mass of chlorine is 35.5, and it says when calculating the relative atomic mass, which particle, like which element in the periodic table, is the mass of chlorine compared to? So we always compare to carbon-12. Scientists just decided that they're going to compare the mass of everything in the world with carbon-12. This question is also one of the very common questions. It asks to identify a covalent compound that has a higher melting point than an ionic compound. So we know that ionic compounds have very, very high melting and boiling points. In covalent, we know that simple covalent compounds have low melting and boiling point, but we know that giant or macromolecular covalent compounds have very, very high melting point, even higher than ionic. So in this case, you're going to just say something like diamond or graphite or silicon 4 oxide. So one of the giant molecular structures. These are covalent and they have very high melting and boiling points. For this question, it asked about the relative molecular mass, or the MR, for this compound, and I'm going to write it again. It's CH3CO2H, and it's simply going to be carbon, so it's 12 times 2 because there's 2 carbons, plus 1 times 4 because there's 4 hydrogens. There's 3 here and 1 here, plus 16 times 2 because there's 2 oxygens. And so this last one is the correct one because it's 12 times 2 and 4 times 1 and 2 times 16. Now this one here, they did first 12 plus 1 and then multiply it by 3, which is wrong. You cannot add the masses first and then multiply it by the number. You first multiply the mass of carbon and then you multiply the mass of carbon times the number of carbons, and same thing with hydrogen. You multiply its mass with the number of hydrogens, same thing with oxygen, and then at the end you add them together. And so the answer here is D. This student here actually, what he or she did is actually they went to one of the periodic tables on the internet that is not our IGCSE periodic table, and that's why they got these fractions and that's why their numbers were messed up. So please go to the official IGCSE periodic table so that you get exact numbers and you don't get those fractions here. Now this is also a very common mistake. It says which one of the following diagrams represent an alloy. So an alloy is a mixture of metal and something else. So L here represents an alloy. Why? Because this is your metal, for example, iron or gold or what have you, and then it's mixed with something else. It has something else randomly mixed in it. It's not regularly arranged like that. It's not one layer of metal A, one layer of metal B, and then metal A, metal B, metal A. No, it's not like that. It's just you have your metal and then the other metal is introduced and it's there randomly. And so it's not as regular as J. The question here says brass is used to make the propellers of ship rather than pure copper or pure zinc. And it wants to ask what the property of brass, which explains this. Why do we use the brass to make propellers of ships? The reason is that brass is hard. Any alloy is harder than the pure metal. So if they use the propellers made of pure copper or pure zinc, what's going to happen is that pure metals are are softer than alloys, so it's going to bend easily, and so that's going to be a problem. I mean, if your propellers bend easily, that's going to be a big problem. So you want it to be hard, and that's why we use alloys to make things like propellers of ships or make bridges, or a lot of things are made of alloys because of this property that it's harder than the pure metal. This question says name the type of structure which has the following compounds have. And so carbon dioxide is a simple ionic compound. It's not ionic, it's simple covalent. And so we know that ionic is a metal plus a non-metal, but carbon dioxide, which is CO2, these are 2 non-metals. Carbon is a non-metal, oxygen is a non-metal, and so they form simple covalent molecules. Now this question, the student did a great job and they almost got the 3 marks, but they will lose 1 mark. Why? So the question says, explain why metals are malleable. And they said this is because they consist of layers of atoms. So the word layers, that's excellent because they have layers that can slide over each other when a force is applied or when it is bent or hammered or pressed. Great. These are great responses. But these are not layers of atoms. They are layers of cations. So make sure you write the correct words. This question is also very common. A lot of students do not know how to answer it right away. It says that there's a substance called fullerene. It has a relative molecular mass, an MR of 840. And it's asking how many carbons are there in one molecule of this substance. So this is basically all carbons. So it's carbon something. And this carbon something, its MR is 840. We know that each carbon is 12. So 12 times something is equal to 840. And all you need to do is just divide, X is going to be 840 divided by 12, and that's going to be 70, which means we have 70 atoms of carbon. Now, a very common question here also, it says which term is defined by the following statement. It says the average mass of naturally occurring atoms that are compared to carbon-12, and this is simply the MR, or the relative molecular mass. I don't want you to write MR. I actually do want you to write the full name of MR, which is relative atomic mass. This is the average mass that's compared to carbon-12. This is another question. It says, explain why iron is malleable. And so when you explain malleability, there are two keywords and 2 marks. You're going to say because the cations are arranged in layers, and these layers can move or can slide over each other when force is applied. So the student here wrote the ions have free to move within the structure. So I don't know what they mean. Maybe they mean electrons are free to move, but that really explains conductivity, and it's not even ion, it's electrons. So I'm not really sure about this response, but basically if it's asking about malleability, then you really have to talk about the layers and the fact that they can slide over each other. Now, this question also very common. It says describe the structure of a typical metal. And the student answered the structure of an atom, and so the students described an atom and not the metal. And so make sure that you read the question very well, because this is very common. Students do not read the question well, and so the student kept on describing the atom. Nucleus is in the middle, electrons are around it, and they drew the structure of a metal, so they unfortunately lost the 2 points. The description of a typical metal is just simply those 3 points for describing a metal. The first point is that it's a lattice of regularly arranged cations surrounded by a sea of delocalized electrons, and there's attractive forces between the cations and the negative electrons. So you just write those 3 points and get the three marks for describing a typical metal. Another common mistake here, describe how substance J, so J is a metal, why metal conducts electricity. You simply say because there are free electrons that can move across the structure and conduct electricity. So what did the student say? They said the positive electrons, electrons are not positive, okay, are highly attracted to the opposite charge as the negative charge. Okay, so I know what the student wants to say. So the student wants to say that these cations, the positive ions, not electrons, are highly attracted to the negatively charged electrons, those sea of delocalized electrons, and this actually makes metals have high melting and boiling point. This is an explanation why metals have high melting and boiling point, is because of this attractive forces. And so this is one concept in regards to high melting and boiling point, but it doesn't explain conductivity. Conductivity is explained due to the free moving electrons and not because of the attractive forces. This question says which substance could be metals. The student chose B. Now, B cannot be a metal because it does not conduct electricity. Metals always conduct electricity. They never are non-conductors. They always conduct electricity. So be careful with a question like that. If they're asking about a metal, it should conduct electricity in all states, whether it's a solid or a liquid. Always conduct electricity. And so you're going to choose C and F. A similar question here, but it has a different idea. It says which element is a good conductor of electricity? And so we're really looking for a metal, and we know that metals have few electrons in the outer shell, so either 1 electron in the outer shell or 2 or 3 electrons in the outer shell. These are non-metals, because they have a lot of electrons in the outer shell, 5 or 6 or 7 or 8. These are also non-metals. However, C is a metal because it has 1 outermost electron, and so for sure this is a metal. For drawing a metallic elements, so this drawing is not not bad, but you have to make the cations tightly packed. So all those circles should be tightly packed. I mean, there's a lot of spaces here. It almost looks like a liquid. And so be careful with those spacings. Don't leave a lot of spaces. Now, the student did a great job putting those positive signs. However, they should also label it and say that these are the positively charged cations. They also missed, or they forgot to draw the delocalized electrons. And so they should also label them and say that these are delocalized electrons.